in 2011 as General Weather Forecaster at the Multi-Hazard Early Warning Center at DGMET Oman. He is currently working as Weather and Climate Research Specialist at Oman Met Department. He is also an expert in remote sensing for weather and climate at the WMO Center of Excellence for Satellite Applications at Muscat. And we welcome you, Ibrahim, for today's talk. Over to you, Ibrahim.
Thank you, Monica. Actually, I should say, wow, I am in front of experts here, and actually you defined me as expert, but yeah, I hope so in future. Yeah, let me share my screen. Entire screen. Waiting for the connection. Okay, can you see my screen now?
Yes, sir.
Okay,
Yes,
thank you
yes.
again. Good morning, good afternoon, good day to all of you. I am Ibrahim Al Abdulsalam, as introduced by Monica kindly. Thank you. I'm going to talk about Arabian Sea tropical cyclones, including sea surface temperature, ocean heat content, and TC history in Arabian Sea and its impact in Oman and Arabian Peninsula, actually, throughout the history. So this is me, and that guy is Tropical Cyclone Qatar 2019. So let me start with some definitions here very quickly. By the way, start with the points, definition of SST, OHC, TCHP, and tropical cyclone cyclogenesis, seasonality of Arabian Sea tropical cyclone, discussing climate change in Arabian Sea and impact on the frequency of tropical cyclone, a brief over tropical cyclone season 2019, a quick look at the recent tropical cyclone TIG, October 2023, and highlighting some issues related to tropical cyclone classification. So let me start with atmosphere ocean coupling, referring to interaction and exchange of energy, momentum, and mass between the atmosphere and ocean, and in different way, exchange of energy like short wave and long wave radiation, conduction and convection, momentum exchange like wind, pressure, sea wave, ocean currents, and mass exchange, of course, as like evaporation, precipitation, and aerosols and other substance. And all of that could be found in tropical cyclone, by the way, and the role of SST and ocean heat content, tropical cyclone, heat potential are always there. And overall, this is of course fully nonlinear, very complex, needs accurate observation, accurate numerical modeling, accurate physical and reality approaches. The other definition is sea surface temperature, SST. In meteorology, the sea surface temperature is defined as temperature of the ocean surface at depth of 0 to 10 meters, theoretically maybe. So here is a schematic drawing showing different definitions of different skin and deepness of sea surface temperature, starting from the interface sea surface temperature through the skin sea surface temperature up to what's so-called the foundation temperature, which is nearly free from any diurnal temperature variation, impact of wind and sunlight, and etc. So this is quite important. Some operational forecast will say, okay, I have only skin sea surface temperature, but looking at these features, there could be a way, I mean, to have a clue about the deeper temperature and heat content of the sea, in case, for example, high skin sea surface temperature with very strong wind that reveal higher that reveal that high temperature is deeper beyond that skin sea surface temperature. This is one case. Different cases can be explained, can be approached from this theoretical view. So impacts on the skin sea surface temperature can be there. This is, for example, Tropical Cyclone Shaheen before, during, and after. And strong wind, strong mixing layer out of this tropical cyclone can be revealed in the skin sea surface temperature. And this is from group of high resolution sea surface temperature. So how we measure sea surface temperature, from my view and from my search on this topic, of course, and as you know, there is different way in situ measurement, for example, buoys, ships, and other floating equipments with sensors to directly measure the temperature of ocean surface beside other air and water parameters. Later on, soon we'll see, for example, sail drone, interesting instrument. But this is more accurate and detailed data. I'm happy with that. We are happy with that, but very limited spatial coverage. So there is, for that, a tropical, satellite-based measurement, mainly infrared and microwave radiometers, estimating the sea surface temperature and calibrating that estimation and validated it with the other SST data. So this provide a wide spatial coverage, but lower accuracy and less temporal details. And of course, when there is cloud, especially with the infrared estimation or infrared measurement, there is a problem. Satellite carrying instrument with the SST capability are many, from NOAA, from METOB, European satellites, Sentinel, Aqua and Terra satellites, Moody's, stuff like that. So then, of course, there is optimal way to utilize these instruments and this data by integrating, for example, here integrating into one system for optimal accuracy, like the GHRSST project, which is very nice and give you a global view of the SST measurement. And this is actually skin sea surface temperature. And this is from I got these animations and these images from Worldview, very famous web platform visualizer. Of course, there is new technologies, very nice technologies like sail drone. This instrument sail through very devastating tropical cyclone and come out with very important measurements. And yeah, you can find different scientific papers discussing these data. And of course, YouTube is there also. I don't want to spend much time here, but let's see for a moment if this is going to work. For tropical cyclone Cat 4, I think. So this is a measurement for wind speed, gust wind, and the wave height. I'll speed up this video in order to save time. It's quite interesting for anyone to look at what's going on under these very devastating, weather phenomena. So this sail drone approaching the eye of the cyclone, then this is the case under or close to the eye. then it safely pass away gradually, I mean. Okay, you can find many YouTube videos about this in YouTube or in other internet platforms. Uh, so this is one interesting equipment. By the way, it can measure not only sea surface temperature. Of course, there are many parameters can be measured in very difficult area. Tropical cyclogenesis ingredients, of course, most of you know about this, but it's good idea, I mean, to introduce it even for myself. Uh, of course, warm sea surface temperature above 26.5 degree deep to down to 50 meters or more or below is very important for cyclogenesis. Pre-existing low pressure system, or maybe sometimes you have a easterly wave passing over this very hot sea surface temperature, then it will say, oh, there is good chance to develop a cyclone or a tropical cyclone here. Uh, Instability is important. High moisture in low and mid troposphere is very important, but more important beside the sea surface temperature is the low vertical wind shear. And Coriolis force, of course, tropical cyclones are happy to rotate, so Coriolis force is required there. And in the image on the right, this is just a quick view. Low pressure can develop over the high sea surface temperature. If there is availability of this list of ingredients, then there could be a cluster of of convective cloud, then more and more a chance to develop tropical storms and maybe tropical cyclone. So another definition, another term to be defined here is the tropical cyclone heat potential, TCHP. It is a subset of ocean heat content, so there is a similarity between them. So tropical cyclone heat potential is defined as the measure of integrated vertical temperature from sea surface temperature to depth of 26 degree isotherm. So whenever you have deeper 26 isotherm, of course, there is, I'm talking about tropical oceans. When there is deeper 26 isotherm, there is more and more thermal content, heat content. So there will be expansion. So that expansion in the water can be measured by altimeters or any other sea level measurements. So good approach by altimeters, and uh, tropical cyclone heat potential is very important, and it is very needed actually to be correlated with the sea surface temperature. This is a kind of measurement and correlation of sea surface temperature with TCHP for North Atlantic tropical cyclone region, June to November 1993 to 2012. It looks that there is a good correlation in North Atlantic region, but in the North Pacific region, the correlation is not, I mean, that much. So this is important actually. These approaches is important to reveal the potential of tropical cyclone formation and intensification in some cases rapid intensification. And the case here, for example, is tropical cyclone Katrina. So tropical cyclone, I need to check the time. Okay, tropical cyclone Katrina is historic in terms of catastrophe or even politically. I mean, it has its history. So it has very rapid intensification in Gulf of Mexico, and that intensification is not that much revealed by sea surface temperature. But when it comes to tropical cyclone heat potential, the mystery is revealed actually. The tropical cyclone encounter a very high TCHP amount, then intensified. I don't remember the category. It was Cat 5. Yeah, it was intensified into Cat 5 and hit the northern coast of Gulf of Mexico. There is an opposite case in Arabian Sea, which was Tropical Cyclone Kayar. Tropical Cyclone Kayar, I mean, developed in east of Arabian Sea, then head to northwest, but it encounter low amount of tropical cyclone heat potential, and I think this is animated here, and you can see clearly how the cyclone itself enhanced that area after it passed over that specific area. Then tropical cyclone Maha, by the way, come after tropical cyclone Kayar, and here it is. Kayar was category 4, then Maha category 3, but it struggled with the very low or zero ocean heat contents. So thanks God, it find no way to go and impact Arabian Peninsula territory or any other area. I did some fun actually with these two cyclones. I analyzed. I used GIS to analyze the track of these cyclones and then look at the sea surface temperature anomalies. The impact is very, very huge, maybe historic for the last 20 years. Then I think I thought about the altimeter, so I found an altimeter passed after the tropical cyclone actually passed over the area, and it reveals and it is measurement for the sea level anomalies that's quite below the average for the region impacted by the tropical cyclone, or as it is already with the low ocean heat contents. Another stuff for fun here, I have added the sea level anomaly graph on the top of the track, on the top of the SST anomaly. Then it reveals how the sea level is below its average. At the end of the day, there is no impact, actually direct impact to anywhere of these tropical cyclones, but there is indirect impact. I'll talk about it in a moment. Arabian Sea surface temperature variation, of course, this is very famous and unique to Arabian Sea to have 2 peaks for sea surface temperature throughout the months, and Bay of Bengal also has something like this, but it's more unique to Arabian Sea because of Indian monsoon wind. Actually, I got this from NOAA optimum interpolated sea surface temperature. It's very coarse resolution, but it's fine. I have checked this data on my own way to validate my analysis. Why we have 2 peaks and why we have reduction in the sea surface temperature through the months July, August, and September. So that's, of course, as you know, because of the Indian monsoon wind. It has very big impact in the sea surface temperature. I have, this looks a little bit exaggerated. I mean, I have changed the scale in order to reveal the impact of this wind. Actually, you can distinguish very easily how hot is, for example, the Gulf and the Red Sea comparing to Arabian Sea, the west side of Arabian Sea. The impact is very high, and this is why we have two seasons of two identified season of tropical cyclone in Arabian Sea before and after monsoon. So imagine imagine Arabian Sea without Indian monsoon wind. How will be the tropical cyclone activities here? History of tropical cyclone affecting Oman. Oman now, it's well known by the impact of tropical cyclones. And you can see tropical cyclones 1890, 1889, and then you know the famous tropical cyclones last 2 decades, for example, Gono and Shuba, and what else, Mikono, you can see them. So this is why we have, yeah, this is the another attempt to show you the two seasons of tropical cyclone in Arabian Sea. What else? Arabian Sea, what's going on actually? People in Arabian Peninsula now, they are familiar with this scene, with this image, because of more accurate and frequent satellite images, social media, stuff like that. But another reason is the climate change. Actually, I have looked at the database of tropical cyclone best track from NOAA historic hurricane tracks, and I have looked at the last 40 years from 1982 to 2021, and then divided this period into 4 decades. The first one shows not that much tropical cyclone, 2 tropical cyclone. But by the way, these tracks is for tropical storm and above. I think I need to switch on my camera anyway. So these are for tropical storms and above these tracks. The first decade, the second, 1992 to 2001, little increase, obvious increase actually. Then 2002 to 2011, there is Gono, very famous Cat 5 tropical cyclone, and followed by FIT. Then 2012 and 2021, guess what? The change is really massive and very recognized. I have looked at the sea surface temperature throughout these periods, and I analyzed it this way for 2 areas in Arabian Sea. One, as I believe, the top right one is in the area of tropical cyclone cyclogenesis, and you can see for each month there is column and sub-column inside representing these different decades, 4 decades. And you can see first period, for example, looking at the month of tropical cyclone development, May and June, you can see how sea surface temperature is getting higher and higher, ending with the last decade. For a bigger area in Arabian Sea, you can see this is, by the way, this is monthly average sea surface temperature, and the increment in the sea surface temperature is there. Of course, another source to validate my analysis, which is IMD Tropical Cyclone Atlas. I have looked to the atlas, filtering tropical cyclonic storm and severe cyclonic storm and above in these charts, and this is for the different 4 periods. The last decade shows us quite clear increase in the tropical cyclone frequency, intensity, and by the way, it looks like the tropical cyclones find their way in different areas in the Arabian Sea. Then I went to another way to analyze the data from the NOAA historic hurricane track. I have filtered the counts of maximum sustained wind and sum them for the wind measurement for 34 knots and above, and I have divided them to the 4 decades, and it's very clear. I mean, the last decade, the sum is very high for tropical storm and above, and on the right there is a sum of maximum sustained wind again for tropical cyclone and above for each year, and very obvious 2019 is very distinguished, and as I know, and someone can correct me, the Indian Ocean dipole is very positive, historically positive for the last 50 years, in this year actually, specifically 2019. Then I did extra selection, extra filtering. I filtered the tropical cyclone here to reveal the amount of energy spend in these times, in these decades. So the last decade is very energetic, and yeah, myself, I don't know what's the case. We can discuss it during the discussion time. In the right, bottom right, there is a sum of maximum sustained wind above 64 knots, and you can see how the last decade was very active. 2022 surprisingly was without any tropical storm, any tropical cyclone, but the rainfall record, there was record rainfall over north of Oman, UAE, during July, and during August, record of rainfall south of Pakistan, part of India. This is estimation from satellites for July and August for the two regions. And by the way, this is a very famous case in Pakistan. And this image from Moody's, I can challenge you actually to find any image from Moody's for the last 20 years with this amount of flood over this part of the world. So this is the case for 2022. I wanted to check how accurate is the NOAA optimal interpolated SST. So I went to this area in month of August during summer monsoon. So I picked up the sea surface temperature for this region, and I know how this summer monsoon wind can impact the air temperature over island here named Masira, and the surface temperature can easily, the air temperature can easily impacted by the wind, and the wind coming from this sea surface area. So the correlation was quite, I was surprised about the correlation. It's 0.77. And I feel like I can trust this data. Again, there is increase in this area for the sea surface temperature with the same analysis for the 4 periods. Tropical Cyclone Kayar, let's move to some cases. Tropical Cyclone Kayar again and Maha. This is before and after analysis for the 2 cyclones. This is the case of sea surface temperature and the sea surface temperature anomaly, and the impact, as I said, was historic actually. It's very, very rare to see, the sea surface temperature in Arabian Sea this way. In fact, also in chlorophyll, of course, there is vertical pumping of water from length, and of course, chlorophyll will show up here. What else? By the way, Kayar didn't touch Oman territory, but yeah, there was swell wave, very kind of severe swell wave impact areas on north of Oman. Yeah, you can see from images here, destructed houses and coastal line, the most actually populated coast in Oman. These images from Sentinel, you can see the impact of washing on these coasts. And interestingly, actually, you can reveal extra features of this impact in Sentinel satellites. This is my city, actually, Saham, and I know this port for fishing, and was severely impacted by swell wave from very, very remote, actually, tropical cyclone in Arabian Sea. Nicely viewed swell waves by Sentinel. The image in the top is from, I don't know, it could be Airtron, but Sentinel can provide you with a chance to validate the swell measurement close the coast. Last tropical cyclone, recent tropical cyclone in Arabian Sea was Tig, October 2023. This is track forecast from GFS and ECMWF. Actually, GFS was kind of bad in this case, comparing to ECMWF, comparing to ICON. Actually, ECMWF did very well for its forecast. These are different runs from 16 October to 23rd of October, and we rely a lot on ECMWF in this case. Kind of rapid intensification taking place for this tropical cyclone, and going back actually, or going to the ocean heat content and 26-degree isotherm depth for September. Actually, this is not October. I couldn't find October analysis from ECMWF. It's still not there, but I don't think there is a much change, and I think this high ocean heat content has influenced the this tropical system to go for rapid intensification. This is another analysis for TIG, October 2023. The track, these dots. And interestingly, there is another approach, another estimation from synthetic aperture radar. I don't remember the satellite with the instrument, but the measurement for the wind was 116, which is GAT 4, while the best track, US best track, was giving 109, which is GAT 3. Another features is the eye or the range of maximum wind before for the tropical cyclone before encountering Sumatra Island. It was with quite small eye. I mean, relatively small eye comparing to other tropical cyclone in Arabian Sea. Then after encountering the Sumatra Island, it maintained bigger eye, but it increased. Actually, it is maximum sustained wind. You can find this analysis from a website. I should put it somewhere here, but maybe at the end of this PowerPoint. We were lucky to have a SAR instrument passed over the cyclone, revealing the strength of this cyclone and giving 116 knots as maximum sustained wind. And by the way, this is kind of symmetric cyclone. All quadrant are, I mean, like a solid ring with maximum sustained wind, like a circular shape. Another approach using what's called SATCON. This is from University of Wisconsin, and it stands for Satellite Consensus Combined Multiple Estimate of Tropical Cyclone intensity from objective intensity algorithms into a single weighted estimate. I'm bringing this up to compare the SAR wind measurement to the best track and other wind estimation. It's on the top actually, as you can see here. And this is an issue. I'll come to this issue in a minute. This is for TIG, and this is, by the way, for Hammond. Hammond, I don't know if I pronounce it correctly. October 2023, and again we are lucky to have another pass of SAR instrument and giving the maximum sustained wind as 104 knots, while the maximum sustained wind given by US best track was 74. So this is 74 Cat 1, and the other one is, I don't know, it's Cat 3, I think. So which one to choose? This is for almost exactly the same time, 12 UTC, with 1 minute different. It's not only the wind, it's also the location. US best track apart from SAR by 44.41 kilometers. Again, SAR wind measurement is on the top of other measurements, including best track. Yep, this is from SATCON. And yeah, I have to think about the historic analysis. I mean, having these new emerging satellite instruments, extra satellite resolutions, development technologies. I put this line arbitrarily, but technologies are there. What's the influence in these historic analysis? These technologies, these instruments can expose, can make exposure of the higher maximum sustained wind, so higher and higher category. Is there impact? I don't know actually. I want to hear from expert in this talk. So I come to end of my talk, and thanks to all of these institutes providing very important data and help me a lot and make my life easier. Thank you.
Thank you, Ibrahim. If there are any questions, you can ask. Dear participants, if there is any question, you can ask. So there are no questions. Thank you, Mr. Ibrahim, for a very
Actually, I have a question.
Yes.
Actually,
Yes.
can someone answer me? I start being worried about these analysis. How much, I mean, emerging new technologies and satellites has influenced these historic data? I mean, is it climate change, or what do you think? More and more technologies can reveal the secret underneath these systems, so more bigger and bigger categorization or much more classification of tropical cyclone. I have seen Dr. Mahabatra and other experts there. Okay, in any way, Monica,
Yes.
thank you. The question will continue to be there for me at least.
What is the question? I have not understood.
Yeah, the question is after analyzing the historic database from NOAA best track. So there is increment on tropical cyclone frequency, intensity in Arabian Sea.
Yes.
But 40 years ago, there was no, for example, SAR technology. No, that much, I mean, satellite with their sophisticated equipments and instruments. Nowadays, we have higher resolution. We have many different passing of high resolution satellites, so that can add up to the measurement, can add up to the data recently.
Yes, but studies also show, we have also published a paper on frequency of genesis and landfalling TCs, and there also we have found that the frequency of intense cyclones is increasing, particularly over the Arabian Sea.
Interesting. So,
Yes,
but
so
any comments on this
matching
technology
with
involved? I mean, now we have seen, I mean, the influence of SAR giving you, and I believe SAR is accurate, giving you higher maximum sustained wind. It's even higher for the tropical cyclone Hamon, which is here, rising it from Cat 1 to Cat 3, rising any, for example, deep depression to a depression to tropical storm, a tropical storm to a tropical cyclone. So this could involve extra and extra tropical cyclone to the list. So it will reveal sort of increment, but it is misleading. I know I can say that there is change in Arabian Sea. Arabian Sea is getting hotter, so we expect more and more tropical cyclone. But the technology is making me worry about this stuff. Anyway, thank you, Monica. Actually, I'm not that expert in the field, but I am very astonished about the data. Those easily can be analyzed and found in the friendly websites.
May I speak something?
Yes, Dr. Mahabatra?
Yeah.
Yeah, please.
So there are two issues what is being flagged during this discussion. One is the rapid intensification, and second one is the increasing trend in the frequency of intense cyclones over Arabian Sea.
Yes.
So there are two different issues. So let me address the second one, that is increasing trend in the frequency of intense cyclones. So there was a committee formed by WMO long back to analyze the trends in genesis, intensity, track, landfall, rate of intensification, associated adverse weather like heavy rainfall, wind, storm surge of the tropical cyclones over the different ocean basins. It was represented by various scientists, and I luckily was member of that group from
Nice.
North Indian Ocean. So we made the study and brought out the results. The results published in 2 papers, that is Bureau of American Meteorological Society, BAMS, in I think 2020. So what is the finding is that, yes, there are certain ocean basins where you have got the impact of the climate change, and there are certain ocean basins where you don't have the impact of the climate change. And specifically, if you look at Northwest Pacific, where frequency is maximum, yes, there is impact of the climate change. That means we can prove with good confidence that increase in greenhouse gas concentration is affecting the increase in intensity of the cyclones over Northwest Pacific. Similarly, over North Atlantic. With respect to Indian Ocean, it was found that if you consider different ocean basins like Bay of Bengal and Arabian Sea, there is an increasing trend in the frequency of the extremely severe cyclone storms over the Arabian Sea. But there is no trend in such frequency over the Bay of Bengal. Considering the total number of cyclones, it is decreasing over Bay of Bengal. Even events of very severe cyclone storm also shows a decreasing trend. But over Arabian Sea, it shows no change in total number of cyclones, but intense cyclones, that is extremely severe cyclone storms, are increasing as the diagram we have shown that it is increasing. You can go to next diagram, please.
Next diagram.
Yeah, next slide. Yeah. This one you are talking about. Okay. Yes. So there is an increasing trend over the Arabian Sea. This is the frequency of Arabian Sea.
This is for Arabian Sea. Yeah.
Fine. And especially if you just look at this increase in with respect to extreme severe cyclone storms. So then we went for analyzing the attributions, so whether it is really because of the climate change or it is a part of natural variability. There could be natural variability because cyclones also show epochal behavior. For 3 decades, there will be higher frequency. For 3 decades, there will be lower frequency. So we found that there are many studies because you have to attribute means there should be some study. The various parameters which are associated with the intensification, that includes, for example, the vertical wind shear, the humidity in the middle tropospheric level, and instability in the atmosphere. That grace parameter, but each parameter was analyzed, and it was some studies suggested that that this frequency of intense cyclones are increasing because the vertical wind shear is decreasing. And they told that this vertical wind shear decrease is mainly because of the dust aerosols coming from the Arabian Peninsula. At the same time, some people told that it is not because of that, it is because of the increase in sea surface temperature and the ocean heat content. So if it is ocean heat content, then the point comes to whether this ocean heat content is, rise in ocean heat content is because of the climate change. Then immediate neighbor is the Bay of Bengal, and Bay of Bengal also shows the rise in sea surface temperature and so rise in ocean heat content. And there was a famous study by, I think, Wang, etc. They showed that with these projections, that frequency of cyclones over Bay of Bengal will increase. Intense cyclones will increase, and Bangladesh will have more cyclones affected. But virtually, what happened really, that frequency of cyclone has decreased. So the basic concept which was utilized by them to say that the climate change is impacting intensity, that could not be proven over Bay of Bengal. The same is the case for Arabian Sea. So while analyzing all these studies, it was found that there is no unanimity among the studies carried out so far to say that intense cyclones are increasing because of the climate change. So what we did actually among all the authors, we took some kind of voting. Okay, how many of you agree that it is because of the climate change? And how many of you agree that it is not because of the climate change? How many will say that there is a low confidence? How many will say that there is a moderate confidence? Or how many will say that there is a high confidence that this rising trend of the intense cyclones Arabian Sea is attributed to climate change or greenhouse gases? So finally, the results. This voting was carried out for all ocean basins. And finally, we came to conclusion that there is a trend, there is a rising trend in frequency of intense cyclones over the Arabian Sea, but there is a low confidence to say that it can be attributed to rise in greenhouse gases. Whereas there was high confidence to say that it can be attributed over the Northwest Pacific Ocean or the North Atlantic. So this is the technology. What you asked, why this increase in intensity? Technology could be one of the technologies, the climate change. So number one that I wanted to explain you, there's a low confidence on that. But certainly that there is a rise in sea surface temperature, there is a rise in ocean heat content, which are the parameters for genesis and intensification. Also, our study shows that the relative humidity at 500 SPL level is increasing over the Arabian Sea. And humidity, as all of us know, that is a very important parameter for intensification, and hence that also can be attributed. But whether that relative humidity increases because of the greenhouse gases, no, that we cannot say. So therefore, the genesis parameter study or the technology leading to intensification are understood to some extent or large extent, like vertical wind shear, ocean heat content, sea surface temperature, mid-level relative humidity, but their attribution is not yet fully understood. Therefore, we say there is a low confidence to say that it is because of the impacts of the climate change. But the another point we have to keep in mind that frequency of cyclones over Arabian Sea is quite less, either once or twice in a year. It's such a low frequency, it is very difficult to define a trend which is robust and which can be attributed to climate change. Now we'll come to the second question, that is rapid intensification. Rapid intensification over our ocean basin is not quite common. It is more common in Pacific and Atlantic, and in our ocean basin, it is not so common. But however, it has occurred in the past, and it has occurred in case of, I think, Kyar or K, and recently it has occurred in Cyclone Amphan or Bay of Bengal. So Arabian Sea intensification has occurred in the past, but when you consider the area, yes, Southwest Arabian Sea or adjoining West Central Arabian Sea, which is prominently a colder region, usually the conditions for rapid intensification are not satisfied because of the colder sea surface temperature and colder ocean heat content. But this time, what happened actually, it was being favored by the upper divergence, you can say, and vertical wind shear, especially the vertical wind shear. So, but still, I will say it needs further study and understanding of the rapid intensification and IOL replacement cycle, which took place during the cyclone, needs further study. Not only for this cyclone, this is an area where R&D is developing, R&D is improving day by day. Still, people do not understand fully the IOL replacement cycle, which occurred in the season associated with the rapid intensification. So these are the gray areas for the research. I think all of you can carry out some research work, bring out some new knowledge about the RI. Then comes whether RI is increasing over the years. The study shows that the rate of intensification is increasing. The rate of intensification is increasing. It is especially proved over the Pacific, Northwest Pacific and Atlantic. So, so therefore, study is needed to find out whether the number of cases of RI is increasing over the years. But again, the problem is that in our ocean basin, the number of cases are less, number one. And then out of that, number of RI cases are also further less. But however, still, we can examine to find out what is the trend in cases of RI, what is the trend in rate of intensification from depression to cyclone, or depression to severe cyclone, or cyclone to extreme severe cyclone, different stages that also need further analysis and research. So these are some of the potential research problems. So all of you can take off and bring some knowledge. Thank you. Am I clear to some extent? Dr. Ibrahim?
Yes, sir.
No, Dr. Ibrahim is here.
He is here, sir. Maybe some connectivity issue.
Okay. But I thank Dr. Ibrahim for his excellent lecture and taking initiative for sharing the knowledge among the WMSK panel countries and other viewers. Thank you.
Any other question? So, thank you, sir.
He raised also another point regarding recently available very accurate wind measurements by the satellites, and the estimate what we give as a best estimate. So whether it's because he is talking about that amount SAR measurements and the estimate, there is a difference. So actually, sir, in that regard, he also asked.
So there will be always a difference because the measurement taken by SAR, satellite, for example, this is the instantaneous wind. And this instantaneous wind, when you convert it into 1 minute wind or 3 minutes wind, certainly the value will reduce. Number one. Number two is that there will be gustiness factor. And gustiness even sometimes can be more than 50% of the maximum sustained wind. So even though we mention maximum sustained wind with gustiness up to 10 to 20%, but there are cases in the past we have seen globally also. Say, for example, in Cyclone Otis, what happened in USA, it was 205 kilometer gust, maximum sustained wind, but in gustiness it was 330 kilometers per hour. Okay. So therefore, gustiness can be even sometimes double the Vmax, that is maximum sustained wind speed. And the prediction of the gustiness is too difficult, and so far it has not been so feasible. Of course, there are certain gust factors predictions, but it is really difficult. And this difference between the actual observations, which is based on SAR, yes, that could be correct. We do not know what is the correct way because the sea area you do not have observations, and SAR is the remotely sensed observations. So there could be some error there itself, but still certainly it is one way of measuring, and it is evolving science. If we can have many such continuous observations with the help of these microwave satellites, perhaps time will come, we'll have the complete coverage of the cyclone area. And again, we may examine whether Vmax can be taken off based on the other technique, or we should go for the actual observation from the SAR. So this is again another area of research to be taken off.
Thank you.
Thank you, Sarah. I didn't recognize that I'm mute, so I just was saying that thank you for very sophisticated actually answer and objective actually answer. And thank you all. Thank you, Monica. Thank you all experts here. I feel like a student actually in front of your expertise.
That's right. We also learn from your presentations, and actually it is a platform to share the knowledge among all.
My pleasure. My pleasure. Thank you.
Thank you. Thank you very much for your excellent presentation.
Thank you so much. Thank you, Monica.
Thank you, everybody. Sir, we can have a group photograph.
Yes.
Yeah, we request all the participants to please on their video.
So all may switch on the camera.
Please switch on your video. Thank you. So let us thank the expert speaker, Mr. Ibrahim from Oman Meteorological Department, for a very informative lecture. And he discussed with us some of the fundamental features associated with tropical cyclones, primarily the role of sea surface temperature and ocean thermal energy, and the impact of climate change on Arabian Sea cyclones. And he demonstrated